Okay, hope everybody's doing well. I'm back at the transformer here for the Snell, I think it's a PS10 subwoofer, and did a lot of some research on that. And Snell, a great guy, Peter Snell was the guy who designed all the Snell stuff, and unfortunately he passed away in 1984 at like the age of 36 or 37. He was kind of like in the prime of his career and stuff. He had designed a whole bunch of really nice speakers and subwoofers and stuff like that. In the later years, he dies. If my information is right, I was reading online. Snell passes away, and by the 90s, I think, some other company takes over Snell. They continue to make products, and then by 2010, they stopped production. They shut down completely. Kind of a shame, but so trying to find a transformer for a product that was made probably, I want to say this subwoofer was probably made in the early 90s or whatever. I don't see any dates on the amplifier and stuff like that, so I'm just taking a guess, an educational guess. All right, so what I'm testing right now, buddy of mine, Gilbert, Gilbert Ochoa, he's a super sharp guy. He builds guitar amps. So, I was telling the story, and I was telling the owner of this amp that I'm working on, that in the 8 years that I worked as a electronic technician repairing home and car audio, and I never replaced a transformer. Maybe one of the other techs, I saw them replace one transformer, but I never did. So it's very rare that they go out. So anyway, but Gilbert suggested, he says, he goes, hey man, here's Hammond, he gave me a whole bunch of different company names to call. And I thought I had them handy, but Triact Electronics, there was a whole bunch of them, but Hammond happens to be one of them. There was another one called Triad, and you can buy all these on DigiKey. They're not a sponsor. So anyway, so I did a deep dive, and what I ended up, originally what I was going to go with was I was going to get two different transformers. One for there's two primaries on this guy. There's the white, these white right here with the center tap, and then there's this guy. So these guys right here, what I find out, these go to a power supply that runs the crossover network and stuff like that, the input signal going into the sub, and the regulators on it are at plus 12 and minus 12. So in the studying I've done, this AC voltage here going to that section needs to be at like 16 volts from the center tap to here, 16, and from here to here, and that's peak voltage. Okay. The other, that was no problem, okay, because I found I can't remember what online book I found, and they showed, let me see if I can, I don't know if it was this one, and they actually showed a power supply like the one that I needed, which is 12 volts and minus 12. Let me see if it's here. If it's not, I'll always come back to it, but I thought maybe, and it was a full, oh, here it is. Is this it? No, that's not it, but that's kind of what it's like. They're just using a different regulator. Oh, here it is. It's right here. So I don't know if y'all can see that, but let me see if I can get it as close, and hopefully it focuses it. So one part of the transformer, this one, has a 16 volt center tap, okay, and then it goes through. Now here they're using the exact same system or exact same electronics to that amp that I'm working on, and so I knew that the transformer because I was going to separate, I was going to get 2 different transformers and then figure out how to put them into the box. So it's 16 volts AC center tap. So the way they put them is, or the way they're the nomenclature, if you will, but they'll put 115 volts. That's the input or the primary side, which is this side, at whatever amps, and then the secondary side over here, the secondary side will be, in this case, it would be 16-0-16. And they may even put the amperage, because it definitely has to supply enough current here to run whatever it is that you're connecting over here. All right, if you don't have enough current, man, the circuit's not going to work. Okay, so this was a piece of cake. I figured, well, I also found a guy online, I can't remember his name, and he was going through the same thing. He was designing designing a 16 watt amplifier, and he goes through the whole math, and I'll kind of go over that. And he talks about how, if you're looking to have, I can't remember what his voltage output needed to be on DC, but you needed to have, like in this case, it's 12 volts DC over here. So your AC over here needs to be at least 4 volts higher than that. So 12 plus 4, math, 16. So this would be 16 center tap. You could possibly go 18 and still get away with it, okay? As long as you have the current, all right? The issue I had was the amp, the main amp. How do, it's like, I don't know. It's the only thing I had to go with was the I knew, let me get my notes here. I knew that, okay, let's see, let me go over here. So this is what I knew, and I know this is probably going to be hard to see, but see if I can put it on there. But I knew, first of all, that obviously the primary side had to be 120 volts at 60 hertz, because that's here in the United States. The secondary side, I already knew, that it had to be either 18 volts, 0, 18 volts, or 16 volts, 0, 16 volts. That was one section, okay? The amp side, all I knew from the specs is that it was a 300 watt. Now, they're not telling you whether it's RMS. This might be peak. And I measured the speaker at 4.7, so we could just say it was a 4 ohm load. And then, of course, I needed to know the power formulas and all that, okay? So from the power, okay, and by the way, I got all this information from a guy online, and I will hopefully put his link on there, because it's the guy's good, okay? So anyway, so and this comes from that formula right there. Okay, just manipulate it. Multiply P by R, then take the square root. Now, he puts 2 here because you have a sinusoidal wave swinging positive and then negative. So you have to count it twice, okay? If I'm not mistaken. So to figure out what the V peak is, we know it's 300 watts for the woofer. It's a 4 ohm times 2. And that's what I did right here. So that's the voltage, 48.99. Okay. Well, the guy suggests, hey, add 4 volts to it. So here it is. We added 4 volts to 49. Well, it should have been 50. So it'd be like 54. Okay. So at this point, I knew I needed to get a transformer that had a 53-0-53. But this is peak. Okay. All right. So how do you, there is a power rating on the transformer. right? Because I mean, it's putting out current. Your speaker's going to handle so much. And so how did I figure that out? How did I figure out how much current I needed? Well, again, we go back to the power formulas. Here are the power formulas. And I went ahead and assumed that I need a transformer with a 53 secondary. And so now I need to figure out how much current I'm going to need because, you know, the bass, man, it's going to take a lot of, that woofer to move it, it takes a lot of power. So here it is. I got this formula. And I said, okay, I peak is equal to 300 watts divided by 53, so 5.66 amps. All right. So now the power, the way they explain power on the transformers is they call it VA. Well, voltage times current is power. Okay, but the reason why they leave it in VA is because they're not including the impedance that's involved in a coil. Because basically in here there's just a coil wire up here or down here and then a coil wire up here, and through magnetic induction we're getting voltage coming out over here. Pretty darn cool how all that works. At least here on this Earth and this planet, that's the way those things work. Who knows? Some other planet, some other universe, if there's another universe, or some other solar system, things may work a little bit different there. So the power that I was looking for, you take the current that is going to be pulled by the speaker times the, you take the V peak over here, and you do twice because, you know, you have the positive swing, negative swing. So it's 106 volts, and then you multiply that by the amp, and so it's 600 VA. Now, that's a huge that's a huge transformer. Okay, so I started doing my digging and found Hammond. And this again, my buddy. What's his name? Gilbert told me, yeah, they make some good stuff. Triac. There were some other companies. But I found these on DigiKey. And the cool thing about DigiKey is you can go in there and type power transformers or transformers. And then you can go, you know, it has it by like the company name. And then it has the type of transformer. And then it has primary voltage, secondary voltage. And then it has secondary current and stuff like that. So I mean, you could go and say, well, I know I need at least 5.6 amps on the secondary. You go click on it, and then you see if the secondary voltage is there for what you're needing, right? In my case, it was like, I just went ahead and rounded this down to like 5, and then was looking for 53. Okay, anyway. So it's very neat. And so what I found was, I found this. This is the Hammond 167 series. Okay. And so, okay, let me explain just real quick. Since I can't find one of these where everything's in there, where I have two different secondaries, you know, one at 53 and one at 16 or 18. I had seen another video where the guy says, hey, if you have an old system and you can't find the transformer because you're going out of business, just buy two separate ones. So I was like, cool, okay. So I did. So the one I found for the primary was a 167P50. That's 250 volt amp, 50 volt center tap at 5 amp. So I'm like, okay, cool, that's going to work. All right, so I, you know, highlighted it. It's 98 bucks and 4 cents. And then for the 16, I had found this one right here, 18. Now, what you got to realize is that's an RMS. It's not peak. So you have to figure out, okay, if this is RMS, what's the peak? Because you don't want to go, let me get this back over here and see if I can find it. back to this guy right here. So, so if you know, if you didn't see this, that hey, this is RMS. Well, the peak over here is not going to be 16 in this case. So if I got this one 16 here that says, let me go up. If I ended up getting this one, this voltage over here is going to be much higher. Okay, not by much, but it's going to be higher. Okay, because of peak value. So how do you figure that out? Well, back to the formulas. Let me see. I wonder if I did it. Yeah, so I did it right here. So you have the formula VRMS is equal to V peak divided by the square root of 2, or it's equal to 0.707 times V peak. So to find the V peak from the secondary on this guy, you're going to take this guy, and which is the voltage VRMS, and you're going to divide by 0.707, and I've done it right here. If I'm not mistaken, I did it right here. Okay. So turns out the 12 volt AC or 12 volt center tap for Hammond, which is this one. Okay, remember this is RMS. The peak value of that is 16.97, which is almost exactly what I needed. Like this is exactly the power supply that's in the amp. Okay, again, this runs the input signal part, the op amps and all that, the crossover section, because they don't need no 50 volts and stuff. Okay, so that's, I mean, you got to be real careful. Now, so I went back and I said, okay, let me see what the 50 volt one, this guy, because remember this is VRMS, so I want to know what the peak value is. Now this is to the amp section, and all I had to go by was that the main huge filter caps on that amp are 80 volts, so you can't go over that on peak value, because then the capacitors aren't going to last you that long. Okay, so here it is, 50 volt from Hammond, 50 volt RMS. Let me go this way. Divided by 0.707 is 70.72, which is awesome. It's perfect. Okay. All right. Now, so that's kind of what I had to go off of to start looking for the two transformers. Okay. One was $37. The other one was going to be $98. So I called my buddy and I told him, I said, hey, you know, you're looking at about $150 something, but there's always a but involved. I said, let me open up the transformer and see if maybe there's something in there, because Gilbert told me, he says, you may be able to repair it, right? And I'll be very honest with you, I was not aware that they have a fusible link, and so actually it's a thermal link, and I don't know if y'all can see that, but it's right there. It's this guy right here. Okay? And that device is a UMI M1 microtemp thermal fuse cutoff, 15 degrees Celsius, 3 amp, and it's 250 volt. That's what that is. It's actually written on there. It's real hard to see, but it's written on there. So I said, okay, let me check the primary winding. Well, that's the resistance. That's 107 mega ohms. Oh, that's weird. I just moved it a little bit and went up. Okay? So this thing is bad. All right, now, in order for you to get voltage, when you have a coil of wire, and then you have a coil of wire here, and you put metal in between it, in order to get voltage on this side, you have to have current that is moving in time, or alternating current. That's the only, if you put a DC voltage over here, for a split second, you'll get a little pulse over here on the secondary. But because DC is direct current, it's not alternating, you're not going to get any voltage on the secondary. You have to have AC on the side. The current has to be alternating. So I said, okay, well, let me just move this guy, and I'm going to bypass that thermal fuse. Let me put it on there. Hopefully it'll come on. Let's see what'll happen here. It should. I'm not sure what's happening here. Let's see. Is it possible my meter is messing up? It's possible my meter is messing up. Yeah, sometimes these guys, you know, through, what do you call it, moisture and stuff, the connections in there may get a little bad. I may have to use another meter because I'm not getting a good measurement on that. That's weird. Let me go down to, yeah, there you go. So now what's happening is that's the actual voltage on the primary coil right there. I'm definitely having an issue with the 2000 mega ohm scale. Okay. So that fuse, that thermal fuse is bad. So anyway, so I told my buddy Gilbert, and he says, well, why did it go out? And I said, well, that's a good question. I really don't know, to be honest with you. I can tell you that this amp, this transformer and the amp is inside the box. And then it's covered with these guys. Okay. And so it probably got just hot, and it's always on. All right. So now, let me show you what I've done. So I came up with this right here. This is my AC. Let me just show you that way, you know. I hope everybody can see that. So this is my, I had this extension cord out in the garage, and I put these guys on it. All right. And so what I'm going to show you now is I'm going to go ahead and turn this to voltage AC, and we're going to measure from the center tap here on the white over here, and hope I don't short anything out. Let me make sure all my leads are up here, not shorting anything out. Let me put that there. All right, and so what I'm going to do is I'm going to bypass that thermal fuse, and we should get about 16 volts, somewhere around there. All right, here it goes. And you may hear this shatter or do that because the magnetic field is setting up. All right, so let's see what will happen here. There it is. Now, what you need to know on this is when you're measuring AC with your meter here, that's RMS. Okay? So you got to remember that. Okay? All right, now let me unplug it. So that's RMS. So the peak value, did I figure out the peak value on that? 16 volts. The peak value would be, oh God, I thought I had figured it out. No, I didn't. Let me get a calculator real quick. And so to figure out the peak value, it's going to be 16. I'm just going to do 16. 16 divided by 0.707. And so it's 22.6 volts. That's the peak value. Okay. All right. So let's go ahead and measure the secondary on the main amp. This is the main amp. The orange one's over here. And I'm just going to go from the center tap. I got to make sure these things don't short out because that'll not be a good day here. All right, so I'm going to go ahead and do from one side over here to the other side over here to the center tap. And so this is going to be going to the main amp. And I want to say it was like 50. It came out to like 50 volts RMS. So here goes. Nothing shorting out. All right, I need to go up to the 200 scale. Let me try it again. There it is, 54.8 volts, that's RMS. And so if we want to find out how much current that is, or rather what the peak value, so that was, let me look at this. Hang on a second. 50, what was it? All right, 54.8. So 54.8 divided by 0.707. I hope everybody can see that. Equals 77 volts peak. And that's still below the 80 volts that the caps have on it. So I've ordered, let's see, that's unplugged. I just want to make sure everything's unplugged and I don't get shocked. So I've ordered I found these at Amazon. I found that UMI M1 microtemp thermo fuse from at Amazon, and they're like, you got to order 5 of them, and it was like $9.73. So now, can there be something else wrong once I put this in? Yeah. I mean, there could be a short in the amplifier, and I turn it on, and we get some nice fireworks. But when I get there, what I'll do is I'll bring out my Variac. It's a variable control voltage, and you slowly turn up the AC voltage. You slowly turn up the AC voltage until you get to about 100, and it has a little current, an amp meter on it. And if it pegs, then you know something's wrong. And if it doesn't peg, then we'll be golden. So I'm hoping that, I'll solder that sucker in there, the thermal fuse, and we'll have it fixed. Okay? All right, so I'm just waiting for parts right now. All right, we'll see you.